Can everyone hear me okay? Is the mic on? Sound good? Awesome. I'm wearing 3 mics, so if you see me bending slightly awkward, I feel like the Terminator almost, yeah, walking with mics. But it's great to high availability. If anything goes wrong, we'll definitely still get the recording. So it's all good. So welcome everyone to the 7 more deadly sins of microservices. Now, I've been working on microservice projects for about sort of 7-ish years. Now, obviously, we didn't call them microservice projects back in 2012. A fellow architect I happen to be working with, we've been burned by some complicated SOA projects, and he was reading some papers around using REST and lightweight services. And that led us into what we now call microservices. But I've done a handful of projects. That project, we made some mistakes, we learned some things. I moved on afterwards to work for a consultancy in London called Open Credo. I did a handful there of microservice projects from enterprises into small companies. And again, we had some successes, some failures. And to be honest, I learned the most from the failures. I've done this talk actually over the last 3 or so years. It started out, I think it was at QCon asked me to do it, to Manuel mentioned during QCon, one of my favorite conferences. They asked me to share some of my sort of mistakes. And that was the original 7 deadly sins, which you can see on the screen. Now, both this version and the version I'm doing tonight are online on InfoQ, and I think YouTube, but the talk constantly evolves every time I give it. I learn more things, I make more mistakes, and I try to weave it in. So this will hopefully be a unique talk tonight. So this is the latest deadly sins, you can see there. Number 1 I'm going to start with, it's going to be a longer exploration because I think one of the key questions is, should you even be using microservices? Yeah, I know it's a bit controversial for a microservice talk, but I think it's a really important question. So we'll spend a fair bit of time on sin 1, but then I'll try and cover as many as I can in the time limit, sharing sort of other just as important lessons around things like communication and deployment and things like that. This is me at Daniel Bryant UK on the Twitters, GitHub, LinkedIn. Love getting involved on Twitter, so at Daniel Bryant UK if you want to tweet some stuff out tonight. I do work as an independent tech consultant, but my largest client is DataWire. And they're Boston-based, a US company. We do a whole bunch of stuff around Kubernetes development experience. I'm branded up tonight. We do the Ambassador open source API gateway. Anyone's used telepresence for debugging on Kubernetes? It's an open source CNCF hosted project. I do a lot of work with Envoy, a lot of work with Kubernetes, all these kind of things. But I have very much realized that technology and people go hand in hand. At the moment, I'm doing more technical stuff, but I realize there's a lot of value in the organizational stuff. Now, Manuel probably is more of an expert in that than me, and Matthew Skelton as well, but I'll share some of my learnings with the people side as well as the tech tonight as well. The first sin is lust, using the latest and greatest tech. Yeah, well, I'm totally guilty of this. But microservices, they solve all our problems, right? Yeah, maybe not. I really think the key use cases for microservices are you cannot scale the people. You're all crowded around a monolith, constantly battling and tripping over each other. That's one use case. The second one is you want to scale the technology independently. This bit of the system wants to scale up more than this bit. The third use case I think is really important is independent deployability. I want to go really fast over here, but this is where I make all my money. I want to go very slow over here. Deploy hundreds of times a day over here, or tens of times a day. Maybe over here I only want to deploy once a day, once a week. Those, I think, are the 3 use cases for microservices. Then, they are kind of popular, so everyone's kind of jumping on board. But I do think in particular, if you're trying to go fast and you haven't got product market fit, as in you don't know what your customer really wants, microservices can slow you down. Yeah? Because you don't know the domain. You don't know how to model your business problem in services yet. Russ Miles, friend of mine from London, fantastic talk where he had 3 very similar projects, and he did 1 microservices first, 1 monolith first, and 1 a hybrid. Massively anecdotal, of course, and a one-off experiment, but he actually learned that the monolith was the fastest way to get going. The hybrid approach, building a monolith but building it with domain-driven design and with appropriate modularization was the best long term, but to go fastest, maybe you need to do that for your funding, a monolith can be the best way of doing things. We're even seeing some people push back. They've done microservices, and now they're rolling back into a monolith. Yeah? I don't know if anyone saw the Segment blog post, July last year. And to be honest, it wasn't so much a failure of microservices, but they really struggled with binary coupling. Yeah? They had their entities that they were deploying onto all these different microservices as a shared library. And that shared library was changing a lot, so it meant they had to redeploy all their microservices all the time. That's actually why they chose not to go with microservices. They rolled back to a more monolithic approach. And I can poke fun at Segment a little bit because I did exactly the same thing on the 2012 project. Java project, I'm not sure how familiar people are with Java, but what I did is I bundled all my entities into a shareable library because we were going to be sending these entities over the wire. So I wanted each side of the service to have the entities to serialize and deserialize. But of course, it was a startup, so we didn't know our business domain. And when the entities kept changing, I had to roll out all of the services every time. I created a distributed monolith, basically, yeah, which is the worst of both worlds. So I totally get why Segment are rolling back. Lots of reading this. Martin Fowler, Stefan Tilkov do a lot of great chats on this. Worth a Google. Understand your business goals. Are you trying to be fast, secure, trying to understand your domain? Understand your business goals before you look at architectures is a key bit of advice. And in terms of architecture skills, this quote by Simon Brown I think is fantastic. If you can't build a well-structured monolith, what makes you think microservices will be the answer? Yes, you can enforce boundaries with network protocols and so forth, but it's all about design. Yeah? There is some benefits that comes by forcing people to use microservices, but design is design. You get it right, you get it wrong, you learn. Microservices don't necessarily, impact that as much as you might think. Simon argues for something in the middle ground. Yeah? Perhaps monolithic or loose kind of components, quite big components, but well designed. A lot of this comes back to David Parnas's work in the 1970s. David Parnas' famous paper about modularization. We've been rehashing it over the years. SOA, microservices, serverless maybe, whatever's next. But Simon's got some fantastic work. I use his C4 architecture all the time. So if you Google C4 architecture, Simon Brown, I guarantee, like me, you'll learn a lot. Simon's almost a mentor now. I've chatted to him so much. I've learned so much from Simon over the years. Now, if you don't like this phrase, this is probably a little bit clearer, yeah, from Alvaro Sanchez, yeah. I won't say any bad words on camera, but you get the point, yeah. If it's bad in a microservice, it's bad in a monolith kind of thing. Do check your architecture design skills. Etsy, billion-dollar company over in the US, famously talk a lot about DevOps, but they are deploying tens of times a day on a PHP monolith. PHP monolith. A lot of people I chat to don't like PHP. It's a fantastic language, I'm not sure why, but PHP monolith, and they're making serious money. Something, if you haven't heard of Etsy, I'm sure you've heard of Stack Overflow. Yeah? Who's visited Stack Overflow in the last week, probably? If you're a developer, yeah, there you go. Who's copied code? Don't tell me. Yeah, Stack Overflow, famously a .NET monolith, primarily. A few services around the edge. They're evolving more towards microservice styles now, but back when I first did this presentation, they were a very well-architected monolith with SQL Server in the back end. .NET SQL Server. Not hipster, but crazy scalable. Yeah, crazy scalable. Do have a think about operational maturity. Martin Fowler did this fantastic blog post, You Must Be This Tall to Ride Microservices. It talks about sort of rapid provisioning, basic monitoring, rapid application deployment. These are 3 prerequisites for anyone thinking of moving to microservices that wants to get a benefit. Yeah? You might get some benefit by modularizing your system, but you really want to go fast, therefore you must have the operations support to do this. Cloud computing is fantastic, but it's quite complicated. I've made so many mistakes on Amazon. I love Amazon stuff, but I've made so many mistakes on Amazon over the years that you do need expertise. Either train your team, bring in a bit of outside help, that kind of thing, but you do need to be operationally aware. I'm sure I'm kind of speaking to this crowd, DevOps crowd, but when I've done this talk to developers and so forth, I like to make this point really clear. Well, there's the link to Martin's stuff. The takeaway, microservices are very useful, but they are just a pattern. Yeah? There's plenty of other patterns out there that can be equally as valid for your chosen business problem. Check your use case, and evaluation is a key skill. Yeah? A bit of upfront thinking can save a whole lot of time further down the development line. And microservices are one of those things, once you've started carving things apart and setting up the operations to support it, it's almost an irreversible decision. Yeah? We have this thing in the industry called type 1 and type 2 decisions. Type 2, you just experiment, you iterate, whatever. Type 1 are the things that when you make that decision, it's going to be with you for a long time. This actually comes from Jeff Bezos and Amazon. I really like the way he's talked about this. You need to identify your type 1 decisions in your project and spend time evaluating those. Should I use microservices? What technology should I use with microservices? There is plenty now, there wasn't in 2012, but there's plenty now of microservice frameworks. Yeah? Everyone is selling you DevOps this, microservices that, Docker, 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 and I love Docker, don't get me wrong, but you've got to learn, we as DevOps engineers, we as architects, evaluation is a key skill. I want to share this quote with you about microservice frameworks, and the quote is, I will postpone using this shiny new microservice framework until my peers have validated the proposed benefits with rigorous scientific experiments. Now this was, of course, said by no programmer, ever, yeah? We just don't do it, do we? But you imagine going into like hospital and the doctor comes up to you and says, oh, I see you've cut your leg. I'm going to try this experimental procedure. Yeah, you'd react in horror, wouldn't you? And I know medicine's not quite the same as software architecture, but hopefully you understand my point. I think a lot of the way the industry is going, the business is getting more demanding, technology is fantastic compared to when I started as a kid, 64K of memory, 8-bit computing. Now I can spin up almost like quantum computers. The biggest skill I think we need to work on as DevOps engineers and architects is this evaluation. Is this understanding of business problems and mapping it to technology? That's a really in-demand skill, I think. As an example, I want to pick on containers. I do a lot of work with Docker, heads up, so I'm very friendly with Docker, but I do like to make this point with sort of containers. I go into some companies and it's Docker, 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 yeah. I'm like, what's your business problem? Docker. What do you want to do? Docker. It's like, no, that's a solution. That's not the problem. But even from a strategic level, I've seen some companies, yeah, we crammed this monolith into a container and we called it a microservice. Yeah. This is, I think it's a hat tip here to, I think this is Casey's slide, Casey West, not my slide, but I've literally gone into an organization where they put this crazy monolith into a container. They put an API, a shim on top, and they're like, yeah, microservices, yeah, it's great. It's like 4 gig image. It's like, that's not a microservice. But you take my point, strategically, if you're involved in the strategic decisions in your business, you really need to think about avoiding rebranding things. Don't just spin up a DevOps team and keep the same engineers and don't train them. That's an ops team, that's not a DevOps team. Yeah. You really got to invest in training, got to make sure your people upskill all the time. I see it at a strategic level, but I also see it at a tech lead level. Tech leads, kind of middle management, get quite excited. I've got all this crufty money-making code. If I can just chop it up and put it in a container, all my problems will go away. The challenge is, a lot of existing money-making code is a little bit of a tire fire. Yeah? Now, I've written my fair share of tire fires. Not intentionally, but it evolves that way. Challenge is, when you try and carve up a tire fire and put it in a container, you literally get tire fire in a container, yeah? And you'll see the firefighters here, you'll all recognize this. This is DevOps, yeah, in our industry, yeah? We can't be picking up the pieces all the time. You really need to, we shouldn't be in this situation, yeah? Good skills to firefight are highly valuable, but we shouldn't be in this situation in the first point. We need to evaluate up front. Things I often recommend, I'm sure many of you bumped into, but things like 12-factor app, understanding how architecture and operations are combined, how best to design an app to operationally succeed in a microservice-style environment. Think about security. Security is super important. There's a whole chapter, I think, or part of a chapter in the book, we talk about that. Things like distroless images, very minimal, even more minimal than Alpine images. Because the more stuff you put in a container, the bigger security attack surface there is. Yeah? You want to minimize your Docker images. Distroless from Google is a fantastic bit of kit. If you're in the Java world, you want to make your jars as small as possible and those kind of things as well. It also, something I call mechanical sympathy. Now, I did a whole talk on this at DockerCon in Barcelona in December, so you can see the slides on my slide share. But for example, anything, for any Java people in the audience, Java pre-version 8, update 131, the JVM was not Docker aware. Yeah? So the JVM would spin up on a machine, and it's the same like with .NET with the CLR, that kind of thing, but the JVM would spin up, and it would look at the host machine and take its kind of parameters from the host machine. So if you're on Amazon and you've got Kubernetes or whatever, spin up a Docker container, it looks and it goes, oh, massive host, 64 cores, 128 megs of, 128 gigs of RAM, brilliant. Now Docker will stop the actual application accessing more than you specify in the world of Docker, but the JVM configures itself wrong. It spins up lots of threads for garbage collection, lots of threads for all concurrency, because it thinks it's got access to more than it can. They fixed this in Java 11 and they've backported it to Java 8, but be aware other languages have similar issues. If you're deploying into containers, it fundamentally changes your fabric you're running on. And as ops engineers, we really need to work with our architecture team to make sure the architects understand that fundamental change that Docker is bringing in. Just some examples there. That was sort of the biggest sin, but hopefully enough to get you thinking about, should I be doing microservices? What kind of things should I be evaluating? What decisions should I be taking? What training should I be bringing into my team? These are really, really important questions. In regard to the second sin, gluttony, it's all about greed, communication lock-in. So has anyone used enterprise service buses, ESBs? Excellent, cool. That's me as well. It's quite an old tech, but when I started my career 15 or so years ago, they were really popular. This thing in the middle did all the communications for you. It did things like service discovery, transforms, things like that. And it looked so nice on an architecture diagram. Yeah? You've got the service A coming in the top there, talking to service H. Service bus did things like security, governance, all these awesome things. But as an architect, I looked at the diagram and I was always horrified. I used to crank open the ESB and communication, service discovery would be somewhat like this. There'd be some security in there as well, somewhat like this. And there'd be some kind of policy, some transformation stuff going on. The point being was, everything became highly coupled. The goal was good, and I'm not knocking SOA. Classical SOA was really good. I think the vendors spoiled it a little bit, and I think we didn't understand some of our goals with classical SOA, and it got a bit productized. But the key thing here was there's a lot of coupling between your application code and code in the ESB. So when you came to deploy things, you often had to deploy in two places. Or you started sharing things inappropriately, and this led to this kind of mess. So the ESB, some of the new lightweight ESBs, like Mule's ESB, really good. Some of the more old school heavyweight ones, quite challenging to work with, if I'm honest. Now, ESBs are usually deployed behind the firewall. They're in your data center, you kind of control them. But let's just, for a hypothetical moment, move our service boundary, our edge down to here. And if we change some of the names there and we say our web apps are up top and our internal services are below that ingress. So this is like that blue line is like the internet boundary, yeah? This looks, is this an ESB or is it an API gateway? Very similar pattern. Now, slight irony because I'm wearing a t-shirt with API gateway on it as well. And one of the open source projects I work on is Ambassador. But one of the key things with ESBs or API gateways is look for coupling. Yeah, with Ambassador, we've built it super lightweight. It's basically a control plane on Envoy. Anyone who's using Envoy proxy, it is a north-south ingress control plane on that. We've kept it super simple. It's all community-driven. The community has driven it to be literally, service discovery, routing, canary releases, rate limiting, some basic stuff. We don't do any transforms. We don't put business logic in the API gateway. Now, I've seen a couple of projects where teams had used Netflix technology. Netflix, I know them well, awesome people, super clever teams, super smart teams. They've done some really interesting things. But some of their things, we in the community only see them a couple of years later when they open source it. So we're looking at echoes of Netflix's technology, and we don't always understand their requirements, their things internally. And they released an open source API gateway called Zool. Fantastic bit of kit, but you could dynamically inject Groovy scripts into it at runtime. So you could dynamically change routes using code. And you could inject any kind of JVM-based, Java-based, Groovy-based code dynamically. And I saw a couple of monsters on projects I went and got involved in where there was high coupling between the Zool API gateway and the services. So when they wanted to do an upgrade of a service, they had to deploy in multiple places. They deployed their service, but they had to very quickly deploy the associated code in the API gateway because someone had dynamically injected some stuff in there. The worst thing is you don't always know what's going on in there. So once some other team has injected a runtime script into Zool, you deploy, and you either break their code or their code breaks yours. Coupling and cohesion are really, really important, even from an operational standpoint. So be very careful with these kind of things. There's a lot of great tech out there. Kong is really good, Apogee, MuleSoft. Have a look around. Do be careful of copying people like Netflix. They are a fantastic company, but you need to really understand their kind of goals, their principles as well. The third sin is greed, and this is all about organizational stuff. It's only a short kind of sin, but in the previous talk, I talk a lot more about this. Conway's Law has almost become a cliche now. Conway's Law. I'm not going to talk too much about that. Just to say that, seriously, I've worked in enough microservice projects to know that they are as much about people as they are tech. Yeah, microservices is one of those things, if you really need it and you get it right, you do need to alter your organization as appropriate to get the most benefit from it. Particularly if you're doing something like a digital transformation or something like that. Both valuable things, but you need to be sort of thinking about all these things. Think about your people goals as much as your tech. Now, when I was working with Open Credo, people used to get phone calls all the time saying, oh, we're stuck with microservices, Docker's broken, Kafka's broken. And we'd say, oh, cool, we need to understand your business before we can help you, and we need to understand your organization. And people used to push back, because when they're paying by the hour, they don't want to spend too much money. Yeah? So the business was an easy convince. We need to understand how you make money. But when we say, can we look at your organizational stuff, they would say, don't worry, we've reformed around squads, chapters, and guilds. The world is rosy. You do not need to look at the organizational stuff. And I'm sure many of you recognize that. It's Spotify. Yeah? And we'd often go in there, and the squads were scrum teams. The chapters were a lunchtime meeting, and the guilds were someone would send an email around with the latest kind of web dev frameworks. Yeah? They literally, they tried to copy Spotify, but in the same time, they just kind of rebranded some of their internal practices. Yeah? You really need to understand the principles, practices, and values. Like Spotify optimize for innovation and time to market. They want to innovate beats or whatever, and they want to do it really fast. Now, if you're building a nuclear reactor software code, innovation and time to market are the least of your concerns. If you're building a nuclear reactor code, you want it to be super secure, and time to market is probably actual proof, mathematical proof is probably more important in a nuclear reactor than say building Spotify or something. Yeah. So do understand why people have formed their companies in the same way. Now, I would say if you're looking at microservices, understanding the project team versus product teams is really important. I really think having a product team, a long-lived team that looks after a collection of services is a very valuable pattern, rather than having project teams that are spun up, build a service, and move on. Or it's a legacy service now. Someone else deals with that service. I think that's an anti-pattern. In my mind, microservices give you that modularization, but they also give you that ownership. So I do think if you're looking for something to learn, rather than copy Spotify, have a look at understanding projects versus products. Project teams, product teams. There's a lot of InfoQ with QCon. We've got a lot of good stuff on that, so shameless plug. It's all free, of course, on InfoQ. Go on to InfoQ, look, hashtag no projects, hashtag product teams. You'll learn, I learned a lot from those people. So sloth. Sloth is all about getting lazy with non-functional or cross-functional requirements. So things like logging and monitoring, security, scalability, that kind of stuff. This is a great quote from Aidan, and it's something I have bumped into time and time again in my career. The driving technical requirements for a system should be identified early to ensure they are properly handled in the subsequent design. Too many times I go into projects and I say, how many people are going to be using this product? Oh, make it scalable. Quite a lot. Oh, I don't know, 100? There's no real analysis done. Yeah. Sometimes I'll say, how secure should we make this product? Because if I'm building a government, I've worked for the UK government, if I'm building a UK government product, there's going to be other state actors attacking that product probably. But if I'm building, Jane and Joe's kind of website for a cafe, I want to make it secure, but not probably as secure as the government website. Yeah? Knowing these things up front for many projects is key. Some quickly spun up projects that you're going to throw away, not a big deal. But I find it really hard in companies I work with to push back and understand, how do I need to architect this framework? How do I need to architect my infrastructure to support the scale and support the security that you want in that? And getting this stuff written down forces people to think about it up front, which is highly valuable. In particular, so Sam Newman, I'm sure many of you know of Sam, like fantastic books he's got out there. It's a few years old now. This is a great talk about application security. I'm sure if you're in an enterprise, this stuff is really valuable information. And the best talk I ever saw about container security, because containers and microservices often go hand in hand, is Aaron Gratifiore. He's written some fantastic papers online with the CIS and various other organizations. I wrote up his talk on InfoQ. I learned so much from it. He talks faster than me, believe it or not, yeah? He talks crazy fast. And I was like, oh, and I watched the video back afterwards, and he talks from everything from like syscalls, real low-level stuff, to organizational use of containers and how to package applications. This stuff is really, really important. I cannot emphasize enough. Lots of book recommendations here, so you look at to peruse at your convenience. But security testing, I'd highly recommend, if you're in the Java world, Find Sec Bugs is a module for find bugs that looks for security anti-patterns using static code analysis techniques. Countless times in projects I've worked on, it has picked up security issues, SQL injection, command line injection, insecure use of random, whole bunch. It basically looks for hundreds of patterns for bad code examples, which we all from time to time put in. OWASP dependency check. It's all very easy in the microservice world to bring in all these frameworks. You need to make sure the code of those is secure as well. And companies like SNCC, companies like OWASP, Aqua will offer you scanning tools if you want to pay for it. And there's open source solutions as well. A real nice framework called BDD Security. BDD Security is a behavior-driven design wrapper over the Z-attack proxy. And the ZAP, Z-attack proxy, is an automated penetration testing tool. It doesn't replace penetration testers, but it's a good security baseline, particularly if you've got lots of microservices. It looks at things like session hijacking, cause, abuse, that kind of stuff. And BDD security allows you to do a given, when, then syntax over this automated penetration testing. Arachne is really nice, focus more on JavaScript as well, but it's all these techniques, all these tools are there. If you want to make sure your servers are secure, Gauntlet and ServerSpec are fantastic tools for automating security checks on your servers. Docker Bench and KubeBench, fantastic open source tools again for making sure that if you're deploying Docker or Kubernetes, you have configured your machines correctly. If you're on Amazon, you've spun up EC2 instances. It's very easy to leave ports open or do daft stuff. I've done it. These tools will highlight those issues for you. Just one example I've found quite useful is static image scanning. See, a lot of developers I work with are not operationally aware. Totally cool. I love ops. I started learning a lot more about ops, but I appreciate some developers just want to write code. Yeah. But when you ask them to deploy microservices in something like a Docker container, they've got to choose a whole bunch of new stuff. Yeah. I've got to bring in an OS to that container. In the Java world, do I run a JDK, a JRE? What type of configuration and stuff? But in particular, this is one of my bugbears, is people often, if they're not operationally aware, they just bring in Ubuntu. Full fat Ubuntu, massive attack surface, yeah. Often it's got sort of known vulnerabilities of an old version they're running. So you can pay Docker, you can pay CoreSQL or Red Hat now, or IBM, whichever they are now. You can pay a lot of companies to do static container scanning, looking for known vulnerabilities. I would totally recommend doing that. But there is open source solutions as well. Now, Claire used to be really tricky to get running, but hat tip to, excuse me, hat tip to Armin. I did this talk, a couple of years ago now, actually, and he has basically wrapped Claire within a Docker container itself. And he's got some instructions online about how to run it. He runs you through all the code examples, so you can check out his GitHub up there. But all you need to do is spin up his Docker image, point it at another Docker image, and it will look for known CVEs, known issues with that current image. And as an example, this is a year or so old now. This has changed. But this was an OpenJDK binary. So a lot of people were using this binary. And I just basically followed Armin's instructions, did a scan, and this is the number of CVEs I found in this. It's about 100 if you can't see it. 100 CVEs. Now, this has been addressed. There's about, I think, 1 CVE in the current OpenJDK binary, which is a very small attack surface. I'm not picking on OpenJDK because I actually work with them, and they're a fantastic team. But I'm just trying to say there is a lot of images out there that people don't really know where they've come from. They don't really know what's in them. Now, Docker have recently announced their certification and verification scheme, which I think is a great thing. But really, this kind of tool should be in your build pipeline. You should be scanning containers continuously. It's all too easy to sneak in a convenient developer tool, which is actually a security risk. Yeah. So these kind of things are super valuable. So moving on. Sin 5 is wrath, and this is about blowing up when bad things happen. So previously I covered more of the tech side, so people familiar with Release It? Michael Nygaard's fantastic book, yeah, see if people hands up. There's a version 2 out, and this is the book that kind of was the precursor that Adrian Cockcroft at Netflix allegedly gave to his dev team, and they built all the chaos tooling. But it talks about design patterns. So I'm sure you're familiar with things like, singleton, observer pattern, flyweight. But these talk about runtime patterns, timeouts, retries, bulkheads, circuit breakers. As engineers, it's really good to understand the principles. And Michael Nygaard's book is an underrated gem. I learned so much from that book. I do think chaos engineering is very interesting. I think it's arguably sort of the new version of DRBC, disaster recovery and business continuity. The tooling has come a long way from the Simian Army, the Chaos Monkeys. It's a fun project to work with and understand. There are commercial tools out there like Gremlin now. Gremlin do some fantastic work in the chaos space, and other open source tools that exist as well. But it really forces you, once you start codifying your operational goals into something like this, it really forces you to think about them. If you're randomly killing container images, randomly injecting noise into the network, you have to really understand how that impacts your services and code accordingly, both from a dev and an ops perspective. So technical stuff is really, really important. But the people side is really important too. And when bad things happen, people are always involved. As a consultant, I like to be this person, yeah, sitting back with a beer later on tonight, it's all good. But the point being is, when something goes on, the people stuff is really, really important, yeah? And it's often the hardest point to kind of get across. So DevOps, I think, it's an all-encompassing term, DevOps. And I think really it should have been called perhaps BuDev Quat Ops, business, dev, QA, ops, because it covers a lot of stuff, but DevOps sounds better, yeah? But hat tip to Manuel, to Matthew Skelton, many people in the industry, there are plenty of resources to understand how the kind of operational side of microservices impacts the dev side and vice versa. How you spin up your dev teams and your ops teams will massively influence not only how you design microservices, but more importantly, how you run and maintain them. So there's a lot of books coming at you tonight, and you can't read them all. I used to have a long commute in London, hence a lot of reading. But even if you just pop along to the websites, just to get an understanding of how, it's very easy to spin up anti-patterns. You have that classic DevOps team, for example, yeah? And then the DevOps team is responsible for the deployment of microservices. They won't let the devs touch it, all these kind of anti-patterns. It's really good to have a basic understanding of how the people side affects the technology side. A little bit of an anti-pattern I see in London a little bit is the sort of DevOps hero myth. You get this consultant charging a lot of money, not me, there's a consultant coming in, promising DevOps hero, DevOps heroine, they're full stack engineer, yeah? And I think the term full stack engineer is a bit over-abused, and I really like what Charity Majors, what she said a year ago now, I think it was, when she was advertising for jobs, for DevOps engineers, for ops engineers, and everyone was coming at her saying, I'm full stack engineer, full stack engineer. And Charity basically fired back on Twitter and said, I'm sorry, but if you're not designing the computer chips and writing the website and doing everything in between, you're not full stack. Yeah, I don't want to hear from you. And it's a really good point, yeah. Like Charity, if you follow her on Twitter, like Mipsy Tipsy on Twitter, she's great value and very clever as well. Quite sharp at times, you have to be careful. But I've learned so much from Charity. And one of the key things was around defining responsibilities. Modern systems, development, cloud, containers, are just too complicated for one person to claim to be able to solve these days. And a key thing I sort of see as an antipattern is people spend a lot of time creating this perfect microservice platform. Sometimes not even deploying microservices on it, bizarrely enough. I've had one company I worked with, they spent a year spinning up a VM-based system on their current DC, and they wrote all this kind of cool stuff, and I went in, we tried to use it, and it just didn't work. And I was like, oh, how come you haven't built the system to support standard CI/CD? And they were like, well, we never chatted to the developers. We never engaged with the developers. And I was like, what? You're building a platform for developers. Day one is a meeting with the development team, surely, yeah? I had a conversation earlier on, actually, same argument with security. If ever you're trying to do kind of, bring in microservices, bring in Docker, you get your security people, get the InfoSec people in the room day one, day zero, because otherwise they're going to pop up later and they're going to have some very valid arguments for why you should not do what you want to do. You've got to shift left, as the saying goes, all these kind of conversations early. Define responsibilities. DevOps is a massive term. I think if you're just getting started with microservices, focus on what matters. And that's CI/CD. I want to be able to have an idea and get it in front of the customer as fast as possible. But I want that to be secure, and I want that to be reliable. I want to understand the fabric I'm deploying onto. Am I deploying onto cloud, where every block store is a SAN? All communication is going over an unreliable network. Am I deploying onto DC? Am I deploying in containers? These kind of things. I want to understand, how can I debug my services? How can I get the logging data? How can I monitor what's going on? These are the really important things to think about, rather than having some super slick pipeline that does crazy cool things, or having some this all-encompassing, all-singing, all-dancing framework with Kubernetes under the hood. Really, you have to think about, how can I deliver business value? Will what I'm doing today be helping other people, helping me to deliver business value? I've totally got suckered into this with containers. Got a bit too excited up front, spent a lot of time understanding containers, and I've learned, it's good stuff now, but I lost sight for a little bit of time of the business problems. Business problems are what we're all here for, yeah? We're here to either add value to customers or help others add value. And these are the things I think in the ops world that are super important. I do see, and I love Kubernetes, did a lot of work with Kubernetes, hence DataWire and so forth, fantastic bit of kit, but it's not for everyone. Some companies I work with spin up OpenShift, which is kind of like Red Hat's take on Kubernetes, Kubernetes API under the hood, but additional PaaS-like functionality on top. Some people are going to manage Kubernetes, AKS, EKS, GKE, take your pick. Some folks are going serverless. Some folks are going platform as a service, Cloud Foundry, very popular, very nice bit of kit. The point I'm trying to make here is, understand your business goals, understand your company skills, your company goals, and choose accordingly. Don't just choose Kubernetes because everyone's talking about it. Don't just choose Docker because everyone's talking about it. They are both fantastic bits of technology, but they come with their own challenges. And I know in particular, I work with a lot of folks in InfoQ that do a lot of Cloud Foundry work in Pivotal, and they are working with people like from big banks. There's plenty of use cases if you go to Pivotal's website, but kind of companies you think could never use PaaS. Kind of companies you think could never use serverless. They are deploying onto Cloud Foundry, and they are doing it very well. Yeah, and they don't have to worry about the ops side of it. That's been largely taken care of with these things. So do think about it. It kind of comes back to the evaluation thing. Understand your business goals, understand your skills, and choose your platform accordingly, because your platform does dictate how you might architect some of those microservices as well. Second from last sin, envy. These are sort of two shorter sins. Just a heads up on this one, some mistakes I've kind of made. I already mentioned where that first project I spun up, I built a distributed monolith by trying to be clever. I tried to package my entities all in one module and share that module amongst the services, not realizing there was a binary coupling there. When I updated something, I had to update all my microservices. In the new world, having one model actually breaks encapsulation. Back when I started my career, there was almost a holy grail looking for one model. I worked with big enterprises that were looking for, one XML-defined perfect model of their world, and it largely didn't exist. Because we actually, we live and we have business problems in a complex, adaptive world. Yeah? Trying to capture all your business requirements in just one model is nearly impossible. You need to look at the problem from many different angles. I do think domain-driven design is a really good topic. Even if you consider yourself an ops engineer, understanding a little bit about DDD is really valuable. There's topics like ubiquitous language. Having the same kind of language when discussing problems is really valuable. Knowing how you carve up, how you exchange data. I've learned a lot from these books. And some of the pushback rather, is the two books, the blue and the red one, are quite verbose, quite thick as well. The green one, the new one, is basically a summary. And you can get most of the info you'll need as DevOps engineers from that book about what DDD is. It really helped me understand how I need to model a business problem in code, and how that deflects deployment and so forth. DDD has been a really valuable skill in my toolbox. A couple of other things. I don't do too much of this now. I usually get skills. I usually bring in expertise in this space, but I've really found it beneficial. And like I mentioned around Simon Brown's work around architecture, I think diagramming architecture, diagramming your infrastructure, the mere act of diagramming forces you to think about things in a different way. And it's the same with context mapping. It's a technique to understand the static view of your system, all the main services, main modules involved. Event storming is the dynamic aspect of your system. Every system has a static, your classic boxes and arrows, and a dynamic component when you've deployed it and it's running. Static and dynamic are two very different things for the same world, but you need to understand them both at many different levels. But when I'm starting out with a project, when I'm trying to understand the business problems, I really like these techniques. There's a great InfoQ article that talks about how to do context mapping. It's a fairly involved process, same as event storming, but bring in, it's Alberto Brandolini, he's fantastic at this stuff. Bring in expertise to bootstrap, and I promise you, it will pay you back. Yeah, I've learned much from Alberto's work. You need to very much understand your domains, messages flowing amongst them, and how the static and the dynamic interact. On that same note, microservices do give you the option to choose different data stores. Mongo here, you have Cassandra here, relational databases. I'd say don't go too crazy. Same with the multiple language thing. Bringing in lots of new languages, the right tool for the job is a great idea, but every language brings operational overhead. Every new data store brings operational overhead. So countless times I've seen people use Mongo and stuff for structured data, and they have a hard time querying it. I'm like, hang on, you've got structured data that you want to query in an unstructured manner, like MySQL, Postgres, will be more than adequate for your problem. On the flip side, I see a whole bunch of folks, and at Open Credo, I had a couple of people I worked with that were wicked smart with Cassandra. We saw so much abuse of Cassandra because people looked at Netflix and thought it was basically MySQL++. They thought it was an extension to MySQL. Oh yeah, it was just, and they used the same data models in Cassandra as they would have done with MySQL. And Cassandra is not MySQL. It's a completely different model. And we made a lot of money off that, to be honest. It was a lot of fun for solving problems. But then we started basically going into companies and trying to get in there before they even started with Cassandra. Because we could save them so much time, so much money, if we could do a workshop with them and teach them how to use Cassandra. All these kind of tools are wicked, but are good, I should say. But you need to understand how to model data, how to operationalize them. Cassandra is quite tricky to operationalize. I say Mongo is the hardest to operationalize in my experience, whereas MySQL and Postgres, not really much of an issue. They've all got their advantages there. Same with graph databases, those kind of things. A lot of cloud vendors offer managed services, and I like using managed services like DynamoDB and those kind of things as well. RDS, that kind of stuff. Final sim is testing. Now, I appreciate it's been a bit of a whirlwind tour tonight, lots of stuff coming at you. This one I think is really important. If you identify more as a developer in the audience, probably more important for you. But testing is hard. Testing is really hard, yeah? And and microservices make it harder. So I say, first off, do try and understand fundamentals. Testing pyramid, been around for countless years now. Really nice way to think about, I need to probably have more unit tests than I do integration, and more integration than component, these kind of things. And Janet and Lisa's fantastic book, Agile Testing and More Agile Testing. I've chatted to them a little bit on Twitter. They are fantastic people. Their books are amazing. They're quite chunky to read, but they're really worth reading. But the key thing I've learned from Lisa and Janet is this model of how we can structure testing. I've got to remember it now. It's business-facing tests versus technology-facing, and supporting the team versus critiquing the product. And it's basically a model to help discussions, to help us choose what kind of testing we should do. And these are really good things to bring into your organization to help the conversations along. They're kind of fundamental models, fundamental principles. Do remember, they are all models, though. And as the joke goes, all models are wrong, some are useful. Yeah? And I do subscribe to that. But I have learned a lot from, as a consultant in particular, using models. I can present something that's well understood, lots of literature behind it, and we can have a sensible conversation, rather than me just trying to make up something which I think is right. Yeah, it might be right, but it might be not. But having like a model like this is really good. As a heads up, though, this model was created before microservices became popular. So this means you can kind of apply this pyramid at an individual service level or the overall system. Yeah? You can have microservices being components within this triangle, and end-to-end and experimental is testing your business use cases. Or you can have the actual microservice itself being that whole triangle, and your service should ideally have a business functionality. And not always the case, but one anti-pattern, if you cannot think of end-to-end tests, or you cannot think of kind of behavior-driven design business tests for a microservice, it's probably been scoped wrong. Yeah. So some good services I've seen are kind of like payment services, where we had like use cases we could write in BDD. Given a transaction of value X with items Y, then, well, when I do this, then I should expect this. We had a few random, on that project, a few random services that were kind of like utility services. Generate me an ID, do these things. And we suddenly realized these were points of coupling. So this model can be useful to detecting whether you scoped your microservices correctly. But it's an interesting way to think at multiple levels. You can run business tests, end-to-end tests, at a service level and at a system level. And you can even do things like contract testing, consumer-driven contracts. I've done some other talks on that. There's some fantastic talks online by other folks on that thing. But I've used Pact is a very nice framework, and Spring Cloud Contract. But when you're doing microservices, there's a lot more things in the mix, a lot more services. So thinking about your testing strategy is really time well spent. Yeah, how much I'm going to spend doing unit testing versus end-to-end of the service versus contracts. Can the services talk to each other versus end-to-end business use cases? There's lots of stuff to read about this. To be fair, this model is very useful, but it is a little bit old and probably needs updating. Well, ta-da! Awesome lady called Cindy Shritaran. Cindy is San Francisco based, works at Apple now, but she's done various interesting kind of worked for various interesting companies, and she is a prolific writer. If you've seen a copy construct on Twitter, that's Cindy. Yeah, and she's now got a book out, actually a little mini book on O'Reilly, and she's talked about a whole lot of interesting things around testing strategies for microservices. Now, I'm very lucky. I've met Cindy late last year, and seriously, one of those people that you just sit down over a coffee and just listen. Right? Very smart, definitely worth reading her articles. She talks about the triangle probably needs to change into more of a funnel. And when I first looked at this, I thought it almost looks like a bit of a marketing gimmick, but it's actually not when you think about it. Because we are modeling complex adaptive systems, complex adaptive business problems. The systems we are creating are kind of complex. They're very hard to if you've got a big-ish microservice system, it's very hard to understand the whole system. It's often hard to understand a monolith, to be fair, but microservices, because it's all message-driven, it's all kind of eventual consistency, can be really hard to understand what's going on. So she definitely says nothing wrong with pre-deployment testing. This triangle provides a lot of value: unit testing, fuzz testing, property-based testing. Nothing wrong with integration testing. This stuff is super, super valuable. But her argument is that it gets to a point with a microservice system when it gets to a certain size that it becomes a complex adaptive system. And therefore, you only have a probability of correctness. You can run all the tests you like in the world. There is only a probability that it will be correct when you deploy and run it in the real world. Too many moving parts. Cloud, containers, the architecture itself, the system itself. And that's why she's arguing that things like monitoring are equally as valuable as testing. Things like chaos testing, distributed tracing, all these kind of things that you're kind of seeing popping up now, like they are the echoes of mistakes many of us have made in previous microservice projects. And Cindy has captured the zeitgeist very nicely. So I cannot recommend Cindy's work enough. It's really good stuff. Also, Ham Vok, I think it is, wrote a very interesting article about microservices on the Martin Fowler blog and sort of how the pyramid should be adapted. I've learned a lot from that article, and I try to do my sort of add my 2 cents, as I say, onto the topic on Medium. So you can check me out. I think it's at Daniel Bryant on UK on Medium as well. I've done a workshop on this, so you can see the slides from my workshop. It's one of those popular workshops. It needs to be improved. It wasn't as good as I wanted it to be. But a lot of people struggle with testing microservices. I had one person that came up to me at the end of the talk, actually, at the end of the tutorial, and showed me their testing strategy. And they had to spin up like 20 Docker containers. They had to, like, I don't know, sacrifice a chicken or something. It was like crazy complicated to get this thing to work every time. And as they explained it all to me, they turned and looked, and they must have seen my face, and they were like, whoa, this is too complicated, isn't it? And I was like, yeah. If you cannot explain your testing setup of your microservice system in less than 10 minutes and not have me completely lost, or anyone completely lost, you've probably made the testing system too hard. And engineers will therefore try to get around that system. Because we're all smart people, yeah? When we see a system that's too hard and slows us down, we work around it, yeah? So testing is really, really important. So hopefully that's a fair bit of information to get you thinking. Apologies, it is quite a lot, but this talk is more of a, not everything will relate to what you're doing, but there's hopefully a few warning signs where I've made mistakes that you don't have to now. Teams I've been on, we've kind of learned a lot of stuff. We wanted to share this with you. So as much as I'm standing here, there is countless other people in the background here that have worked with me, have mentored me, helped me. That I can't name them all, but they've all been super, super useful in my journey to trying to get better at what I do and share with you. So these are the kind of the sins. I'll leave them out if you do want to take a picture and tweet or whatever. But just think about evaluation. Think about communications, north-south API gateway stuff. Think about east-west, maybe service meshes you want to look at. Maybe you want to do things via libraries, but just think about these things. Think about the organizational stuff. Think about cross-functional requirements, security, scalability, and then test them. Test the NFRs. When bad things happen, there is technological solutions and there is people solutions. Remember that person holding the beer I said I wanted to be? You've got to think about both angles, technological and people solutions. Do think about modeling your business problem and how that relates to data stores, but also events and how data flows around your system, all these kind of things. It's a brave new world with microservices. But learning things like domain-driven design, super valuable. And lastly, testing is where I've probably made the most mistakes and learned the most. I'm still learning, totally. Cindy and Charity, I mentioned already, have helped me a lot in this space. But testing is one of those things that's very easy to forget. Development and operations are pretty exciting, but the testing stuff, not so much. We've even got SRE now, but SRE doesn't really cover testing. Site reliability engineering doesn't really cover testing. So do spend a bit of time thinking about testing. If there wasn't enough books in the presentation already, yeah, I want to treat you with this. I genuinely love reading on all topics, but I like to share where some of my thinkings come from. Some of my thinking is from projects, obviously. Some of my thinking is from conferences and talks, but I do genuinely learn a lot from people from books. So I wanted to put up the books. Shameless plug for Abraham and my book as well. But these are things that have helped me on my, over several years I've read these, and I'll put the slides online so you can get the slides later, and I'm sure the DevOps Lisbon team will share them with you. On that note, I shall say thank you very much for your time.
We're open to questions. You're going to have to speak out loud so we can all hear. Any questions?
I'm not sure if you will hear me because I'm on the thing. So Daniel, thank you very much for your talk. I think we all agree that there was a lot of hints that are incredibly useful.
Thank you.
And I am really looking forward to the video because I will watch it like 3 times.
Thank you.
To get a handle on everything. But I think that we also agree that most of them are very useful for the early stage of company. So those are hints that are super useful before we commit those sins.
Yes.
But probably most of us is working in the companies that have already committed many of them multiple times. We are deep shit. And right now we are coming back to work and we will see all those things that you have just listed and we will have this epiphany. Okay, oh my gosh, there are so many things that we need to fix. But the thing is that we often are at the end of the food chain. And we have to not only convince the business when there will be a lot of nodding and agreement that we need to fix that, of course, wherever you just said. But then we also have to deal with the engineers who will understand a little bit more. But then at the end of the day, we have our daily work, right?
Yeah.
So we don't have time for improvements, right? We have our daily work. So maybe if you could share an idea, one more tip, how to start this conversation. Maybe there are some business metrics that you would suggest that we take a look at to start this conversation and to bring awareness to the companies?
Yeah, sure thing. So just summarizing for the video. Often you find that sins have already been committed, a lot of things I talked about there. What would be the guidance to kind of drive awareness of some of these sins and then try to get sort of our behavior back into a way where we can perhaps undo some of the problems or in theory, sort of, become better. So I'll start by saying perhaps a little bit of a cop-out answer, but there's 2 books I would totally recommend. I know I love my books, but I don't know if I've actually put that one. I read it recently. The one book is a book called Accelerate by Nicole Forsgren, Jess Humble, Gene Kim, fantastic book. I think Manuel knows them better than I do, and there's people there. But there's 4 key metrics, and I'm probably going to get them wrong, but Nicole talks about mean time between failure, and there is lead time, so from the idea to adding value, deployment, I think frequency. There's 4 key metrics the book talks about. And as simple as those metrics are, they are really indicative of the state of your business. And they can be related often to engineering goals and business goals. Now, I think I empathize with you because, to be honest, what you described is a lot of what I do as a consultant, kind of going in and trying to nudge people to think about these things. And you're right, a lot of things are, when I go into a company, I'm only there because they've already gone wrong. But I do think having some of these core metrics and actually going through, a lot of times I go into companies, they're not really aware of how many deployments they've done. They're not really aware of how many deployments failed and how long it took to fix. And they're also often not aware of how long from an idea to adding business value, how long that process takes. Idea, pitch to the board, get approval, code it, test it, like value stream mapping. So there's one technique. So those 4 key metrics that Nicole and Jez talk about, they're my recommendation. They have done a lot more research than I could ever do, and they are very smart people as well. And I think from those 4 key metrics, often by going into your business and say, hey, look, hundreds of other companies are thinking that these metrics correlate with what they call high-performing organizations. And they're big banks, they're big telecoms providers, they're not just startups or whatever, they're big companies, and they've got the data to back it up. It's often easy to get in with the business by saying, look, these companies are on, there's an awesome conference called DevOps Enterprise Summit, I had it mentioned already tonight, but there's big organizations talking about their DevOps journeys, with microservices and without, but a lot of them will reference this work by Nicole and Jez and so forth. So you can often say, look, these big companies are following this work. Can we do this? And often by the simple act, it seems quite harmless. 4 metrics. If I can start recording or digging in and understanding, But Nicole and Jez talk, and Jean talk a lot about, once you've got those 4 metrics, it's often very enlightening because you can tie failure back often to a dollar or euro value. You know, I know if my website is down, it's costing me €1,000 per hour, these kind of things. So you can do a lot of metrics to, you know, understand what each part of the business needs to be motivated. Some people it will be money, some people it will be the training, for example, and some people it will be retention or hiring. You've got to understand what thing you need to poke for the various people in your organization, and it's a hard job to do all this, but from those 4 key metrics, you can often infer things that are relevant, if that makes sense. So a slightly long-winded answer, did that help a little bit, or?
Oh, definitely.
Yeah, so the takeaway, yeah, the takeaway is the Accelerate book is amazing. Yeah, like that is a fantastic. If you filled out the DevOps Enterprise, the DevOps survey, I think it was the State of DevOps. I'm sure many of you filled that out. It's like Nicole, Jez, and Jean are basically distilled their work over the years on the DevOps survey and put it into a not too thick book. But it's one of those books where every page I read, I was like, whoa. I thought some of these things, but they've just put it in a real nice way. And once it's in book form, you can very much, you know, give it to your manager. Say, Happy Christmas or Happy Easter. Whatever, yeah? Like, just put it on the desk, yeah? And I've actually done that. A couple of projects I worked on, it was before Accelerate, but it was Phoenix Project. It's a classic book, yeah? And I often start book clubs. Whenever I go into organizations, I start, because I love reading, yeah? But I say, hey, let's meet after, you know, I try to do it in work time, because I don't think you should give up your social time, to be honest. But sometimes it's, you know, after work sessions, sometimes it's lunchtime sessions. But I try to encourage people to read books. And I'll bring in the tech leadership. Bring in the CTO, bring in the VP of engineering, and say, oh, this, you know, Phoenix Project, nearly everyone's heard of it now, but get them to read it. And honestly, like, I've had some really awkward dinners. Well, I had this really awkward dinner where I went out with all the senior leadership team. I was talking about the Phoenix Project, and there's a character called Brent in it, who's like the kind of, you know, person that basically takes on way too much and is the central failure point of the organization. And as I was talking, one of the senior engineers, his face went white. And he went, I'm Brent. Yeah? And I was like, oh my God. So I had to like rescue that dinner. But the point being is books can be really powerful. Yeah, if you know, get them reading these things. And he had a bit of an epiphany. He was like, I need to change the way I lead my team. Like that was one example of that book. So starting book clubs and stuff can actually be really valuable.
Yeah, I guess that's my answer.
Yeah, cool.
More questions? No?
It's getting late, I guess, isn't it?
One more?
It's about convincing management. It's a bit like this, but the thing is, I believe in prototyping. So it could be something like that in business, because I can share an experience. We had microservices, and we had a lot of logging to it to identify the starting point.
Yep.
So we invested in logging across all systems, and well, now we are faster. And I think that that's a good thing when you have the customer, you have to respond almost in real time, and understand what they're doing. And so there's a euro value for that. And when you have an installer capacity to deal with something, then you will increase your installer capacity by changing something. But usually it starts with some prototyping and showing how easy, and making some quick Excel about man hours and all that.
Yeah, I like that. No, good. It was a great comment. So definitely, like something I've learned with, as a consultant, I've had like 100 jobs because I've worked with so many different companies, and something I've very much seen is a lot of companies, as the gentleman just said there, really like prototyping. It's very hard often to convince someone by doing a talk. You know, it's very easy to stand up, well, relatively easy to stand up, do a talk, try to convince, but kind of much as like money talks, as they say, building a prototype talks as well, because you can actually say, this is the euro value of what things cost, and my prototype here, and can affect that. I definitely think a key thing to add on to that is know the context of your organization. Something that's one of the skills I developed as a consultant, which I didn't expect to, but was and it's sometimes bad, but you learn to stereotype organizations and people. So some organizations, a POC is the only way to get anything done. Others, you have to first convince the CTO, because otherwise any POC will be stonewalled. But you realize, one thing by seeing many different companies, is I got to like almost a sixth sense, and that's not a great thing to say on stage, but I think it can't be replicated. But the way I did it was really understanding the context, really understanding what motivated people, and then reacting accordingly. And a POC, to be honest, is a fantastic way of demonstrating business value. So, yeah, I like that.
Thank you again.
No worries. Thank you.